Hello and welcome to SudoKanard. I wish you a Happy New Year 2023. And this is a puzzle that I created for the occasion, the passage from 2022 to 2023. And this is written here. There's another 2023 here. You see that I tried to make those clues consecutive, but I couldn't hold it till the end. So this is an exam Sudoku, which means that whenever you have a clue on the outside, then this clue is the sum of the first few digits and how many digits is written here. For example, if this is a 3, then it means that 14 is the sum of the first 3 digits. For example, this could be a 6 and a 5. So that's it. As usual, you can find in the description a link to the blog entry where I published this puzzle and a link to this very penpa link, this very penpa interface where you can solve the puzzle before watching my solve or even not watching it. So let's begin with asking how many digits can produce a sum of 36. Well, the sum of 5 digits is at most 5, 6, 7, 8, 9. That's 35. So 5 is not enough. It could be 6. It could be 7. It could be 8. Except that 8 here would need that those 8 digits sum to 36. And then it would mean that the remaining digit to go to a total of 45 would have to be a 9. But a 9 here would mean that the sum of all 9 digits is 12, which is not true, obviously. So we can remove this option 8. 37 needs at least 6 digits, 7 or 8. But if I try to put an 8 here, then those 8 digits here sum to 37, which means that the remaining digits must be an 8, and this is forbidden. So this is also 6 or 7, so we begin with a 6-7 pair. Then something similar is happening down there. This 36 is 6, 7, or 8, but this time 8 would work with a 9 here, and there's nothing that can prevent this at this point. 35 could be as low as 5. It couldn't be an 8, because then this would have to be a 10. So this is 6, 5, 6, or 7. Let's move on to those. Perhaps 11 could be a 2 with a 9 here. It could also be a 3 with 2 digits summing to 8, but 4 wouldn't work, because then we would have to make 7 with 3 digits, and the only way to produce 7 with 3 digits is 1, 2, 4, and then 4 would have to repeat. So only 2 and 3 are possible here. For this 12, 2 is not an option. This can't ever be a 10, not in the context of this Sudoku at least. 3 would work with 2 digits summing to 9. There are plenty of options. And 4 would also work with 1, 2, and 5, and you could check that this would be the only way of achieving this 10 sum. All right, so 3 or 4 at this point. So you see that there are lots of options, actually, at this point. Let's have a look at those. And actually, this is the real place to start. And, well, 2022, 2023, you can guess that those are the first clues that I put in the puzzle. And those are close numbers. So the digits that are possible here should be more or less the same. And this is what will allow us to kind of break into the puzzle. So what happens with 20? 3 would work with an 8 and a 9. So as little as 3 is possible. 4 could work, 5 could work. I let you find possibilities with those. The same happens here, and the same happens here. Well, we have a look at some points. Actually, 3 is not possible here. Because if this is a 3, then we get 8 and 9, we get 20 here, and here we get 25. And now how do we make 35 with 25 plus 10, but nothing here makes 10? So 3 is actually not an option in this case. So let's move on to this 22. Sorry. 6 is not possible because the sum of the numbers from 1 to 6 is 21. So sum of 6 digits, 6 different digits, will never be 20. And here, so 3 is not enough. The most you can make with 3 is 3, 8, 9, that's 20. So at least 4. 5 would work, and actually 6 wouldn't work. Because if you try, well, I said earlier that the sum of digits from 1 to 6 is 21. If you want to make 22 with 6 digits, then you have to add 1 to one of those. But the only one that you can increase is this one. And you can see that 6 does not belong to this set of digits. So 6 is actually not an option in here. And then we get a 3, 4, 5 triple in here. We need the 3 digits to fill in those cells, so we know that we will have a 3, a 4, and a 5 into those cells. So this here is neither 3, 4, nor 5, so this is at least 6, and it can't be more than 6 because the sum of the first 7 digits is 28. So that is a 6, and that's the first digits. And it means that the sum of those 3 digits is 23. So the remaining 3 digits here have a sum of 22. And 22 with 2 digits has only 2 options, 5, 8, 9 and 6, 7, 9. But 6, 7, 9 is not possible because there's already the 6. So the only option here is 5, 8, 9. And we can remove 5 from this cell. The sum of 9 digits would be 45, so that's not a 9. The sum of 8 digits would be everything but this 6. It would be 39, not 29. So this has to be a 5. So we have 22 here, and we must have 29 here. So those 2 digits sum to 7. Without using the 5, without using the 6, those are 3 and 4. And we have 1, 2, and 7 in those. So now this 23 is fulfilled, this 29 is also fulfilled. So where is the next place of interest? Well, there are several options. What about this 23? We can see that this 23 is not a 6, so it's at most 5, so it will be 4 or 5. And we get a 4-5 pair in here. Because of this, so we know that this 14 can't be a 4 nor a 5, and actually 5 would be at least 15, a sum of 15. So 5 was not an option anyway. 2 wouldn't work. So only 3 is available for this. And those 2 digits sum to 11. Without using 3, 4, or 5, the only option is 2 plus 9. All right, now let's consider 22 is the sum of those digits or those digits. And if we sum those digits, we get a total of 36. So if this were a 5, then this would have to be a 9 to get a total of 45, but 9 is not available. So 5 here is not possible, that's a 4. So those 4 digits sum to 22, those 3 to 14. So those 2 sum to 9 without using 2, 3, or 4. So those are 1 and 8. And I must tell you something. I don't remember ever doing this reasoning when I tested the puzzle, when I created it. So it just shows that there are several ways to solve such a puzzle. Now the remaining digits here are 4, 5, and 6. We can see that there's 5, 6, and 7, sorry. There's a 5, 6, 7 triple in here, and the 5 is in here. So that's not a 5, and that's not a 5 either. So that's a 3 coming with 8 and 9. And we get 1 to carry here. And that's a 5. So 5 digits summing to 20. There are several options. This row still needs an 8, but 8 is not here because of this pair, so 8 is here, and here those are a 3 and a 9. Those 3 digits are 2, 4, and 5. And those 3 digits are 1, 6, and 7. Something interesting here is that because the first few digits have a sum of 35, then the last few digits must have a sum of 10. So we must find how digits here sum to 10. We can see that 5 plus 6 works. 5 plus 1 plus 2 plus 3 would work. Actually, 4 plus 1 plus 2 plus 3 would work. But then it would mean that 35 would have to be the sum of 5 digits, and 5 is not an option here. So that wouldn't work. So 4, 6 works. 5, 1, 2, we will need a repeated 2. So the only valid option is actually 4 and 6 here. So that's a 5. There's no 6 in here. So this 6 makes this a 7, and actually that's logical because those 2 digits sum to 10. Those 7 digits will sum to 35. But now, because of this 20, we have 10 here, we need another 10 here, so this is 1 or 8. Where else can we look? This 31 is the sum of at least 5 digits, because the sum of 4 digits is at most 30, but 5 is not available, 7 and 8 are not available, and 9 is not an option. Actually, all the digits are here. Only 6 works here. So all of this is 31. We need another 14 in here. And something interesting is that this 5 must be in here. So we have 5 and 2 digits summing to 9. It might be too early to look at this. First, let's do something similar with this 36, similar to what I did with 35. So this is not a 7 just by Sudoku. If this is 8, then this will be a 9. That works. If this is 6, then those 3 digits must sum to 9. And this is actually possible with 3, 5, and 1. So there's nothing really to gain with that. Something more interesting seems to be this 36. The first 2 digits here sum to 9. And the interesting part is that some digits sum to 9, and after that, we must go to 12. So some digits thereafter must sum to 3. And so what happens if this is a 7? If this is a 7, then this plus that must be 9. So it could be a 4 and a 5. It couldn't be a 3 and a 6. And actually, I'm noticing this. What if this is a 2? Then this becomes a 9, this becomes a 5. And the sum of those 3 digits will be bigger than 14, which would break this 31 as the sum of 6 digits. So that doesn't work. This is not a 2. So that's a 3, that's a 4. And now, so the sum of those few digits must be 9. And with the 4, we could have 4, 3, 2, but 3 is not available. So the only other option is to put a 5 here. And finally, 9 is the sum of those 2 digits, so that's a 7, and that's a 6. Well, actually, there was another way of proving that, and I remember now that this is the intended deduction that I had when I created the puzzle. Here we have a 3, a 4, and a 5. And in this area, 3, 4, and 5 must all be here. And if I put a 2 here and a 9 there, then there's no way of putting 3, 4, and 5 in this 2 by 2 square. And that was my initial argument, actually. So this is not a 2, that's a 3, that's a 4, and that's a 5, as I mentioned earlier, and this is a 7, and that's a 6. So no 7 in here, a 7 there. So 12. The sum of 4 digits must be 12. We already have 9, so the remaining 2 digits must have a sum of 3. There must be a 1 and a 2. And this 5 now makes this a 6 and this a 5. What next? Here those digits are from 3, 8, and 9. What about this 34? How many digits will we have to use? Well, we already see that 4 digits are not enough. I mentioned this earlier. 5 and 6 and 8 are not available. Only 7 remains. And it means that the sum of those 2 digits is 11. So what could this be? It would never be 5 plus 6. It would never be 7 plus 4. It could still be 2 and 8. No, sorry, 2 and 9 or 3 and 8. But 3 and 8 won't work because there would be no possibilities for those 2 digits. So this is a 2-9 pair. There's no 9 in here. There's no 2 in here. And actually, because of this 7, that's a 1 and that's a 7. Now this 3-8 pair makes this a 9, this an 8. Here we have 1, 8, and 9. And we see that this is not 8. And this column needs a 7. It's here. That's a 4-6 pair. All right, where can we still gain some knowledge? Something to do. This 5 is not here. It's not here because there's already a 5 on this row, so 5 in the column must be here. I need a 3 somewhere, not sure where. This column still needs 2, 4, and 9 because of this, and because of this 9, that's the 2. And we have a 4-9 pair in here. Here we need 1, 3, and 4, and because of those digits, that's the 1. That's not the 4, that's 1 at the top, that's a 3, that's a 4. Nice. That's not a 1 anymore. I need a 5 somewhere in here, not sure where. 1, 2, 8, 9, so this is 2 or 8. And actually 1 can only be here in this column. Those 4 digits must sum to 20, so that's the 9, that's the 2, that's the 8, that's the 9, that's the 2. Here we need 3, 6, and 8. What remains to be done in all of this? This 20 I haven't used yet. We already have 6. The remaining 3 digits, or is it the place to look? Oh, sorry, this 11 can only be made with a 1 here. This one disambiguates the 2 and the 1 on top, the 9 and the 2 in here. Well, this 6 is also interesting because of this 37. The remaining 3 digits must sum to 8 without using 3 or 5, so they must be 1, 2, and 5. This is from 6, 8, and 9. There has to be a 7 somewhere in here. This 2 and 5 make this a 4. And here we need 3, 8, and 9. I think that's correct. That's not a 9. We get a 3-8 pair here, so that's a 6. Here we need a 4 and a 5. So we will soon know a little more about this 20 sum. Let's ponder the missing digits here. 1 and 2 are not in here, so they are here, and those are 6 and 7. So we need those 3 digits to sum to 14. And it seems like a lot of options to try, but just notice that those two digits must have a sum lower than 14. So this can never be an 8 or a 9, or the sum of those two digits would be bigger than 14. So that has to be the 3, 8, 9, 3, 8. And now those, well, that's a 6, 7 pair, so that's a 4 with the 6. 9 and 4 here, that's 8, that's 3. And now, so for this 20, I already have 13 here, so that's 7, that's 6, that's 8, 9 and 8, and 6 here, and the rest should be pretty straightforward. 1 and 8 here, 2 and 1, 5 and 2, 4 and 5, 3 and 4, 9 and 3, and finally 9 and 7, and that's it. So I probably didn't take the shortest route. I definitely did not take the route of how I created the puzzle. I just tried to put an outsider point of view, and I think this outsider point of view happened to work as well. I hoped you enjoyed this puzzle of mine. I wish you again a very good year 2023, and see you soon on SudoKanard.